All right, diving right in, you send us, Meritorious Consultants LLC, a guide to key construction industry terminologies and advanced technical terms. We're going to break it down.
Good one.
It is. And, construction, it's such a fascinating blend of science, art, problem solving, and this guide, it's like our backstage pass to that world.
Yeah, and a lot of people, they see a building. They don't think about all the things that go on behind the scenes.
Right. Like, how does it even stand up?
Exactly,
So
exactly.
the guide starts off with like the basic materials, aggregates, cement, concrete. I have to admit, I sometimes get those confused.
It's really common. A lot of people mix those up.
Can you kind of clarify?
Yeah. So think of it this way. You've got your aggregates. Those are your building blocks, your sand, your gravel, your crushed stone. Then cement is the glue. It's that fine powder that when you mix it with water, it has a chemical reaction. It hardens, and it binds those aggregates together.
Okay.
And that's what gives you concrete.
So concrete isn't just one thing, it's a combination.
It's a combination. Exactly.
And I'm guessing different combinations create different types of concrete.
Exactly. You wouldn't use the same concrete for a sidewalk as you would for a skyscraper, right?
Right.
So the strength, the durability, even the appearance, it varies depending on the mix.
That's so interesting. So there's like a whole science dedicated to concrete.
Oh, absolutely. I mean, it's a
Sure.
constantly evolving field. Researchers are always coming up with new concrete technologies. You've got things like self-healing concrete, so if it cracks, it can actually repair itself.
What?
Yeah. Or ultra-high performance concrete that can withstand incredible forces.
Okay, so that's amazing. We've got our foundation laid with these incredible concrete mixes. What comes next in our little construction journey?
Well, now we've got to shape it,
Yeah.
right? So that's where you think of those iconic structural elements, your beams, your columns, and your foundations. And they all work together to transfer the loads of the building all the way down to the ground.
So those beams, those are the horizontal structures I always see.
Exactly. Beams span openings, so like doors, windows, and they support floors, roofs, anything above them.
Got it.
And they come in a bunch of different shapes. You probably heard of the I-beam. It looks like an I or a T-beam. Those are designed to handle different kinds of loads.
And columns are the vertical supports?
Yeah. So columns, they transfer the load from the beams and slabs down to the foundation. So you'll often see them working together, the beam resting on a column, and that creates a strong, stable framework.
So it's all starting to click into place. And then, of course, we have the foundation. That's what literally everything rests upon.
Yeah. And foundations, they're anything but simple. You've got your shallow foundations like slab on grade or strip footings. Those are for lighter structures where the soil is nice and stable. But then you've got your deep foundations. Those are your piles or caissons. And they're driven deep into the ground, sometimes hundreds of feet, to reach really stable strata.
So if you're building, say, on a steep hillside or near a body of water, you might need a more complex foundation.
Exactly. Soil conditions are huge, but also the size of the building, the design, all of that plays into choosing the right foundation.
So we have our beams, our columns, foundations. That's like the bones of a building. But what about the other materials that hold it all together?
Right.
The guide mentions mortar and rebar.
Yeah. Those are the supporting players.
Okay.
So mortar, that's made from a mix of cement, sand, and water, and it acts like the glue that binds bricks or stones together.
Okay, so it's specifically for masonry, not concrete.
That's right. Each has its specific use and composition.
So then rebar, tell me about that.
Yeah, rebar, that stands for reinforcing bar, and it's basically steel muscle within concrete. So you've got these steel rods embedded in the concrete.
Okay.
And that gives it tensile strength, it prevents cracks, makes it much more resilient, especially during earthquakes or under really heavy loads.
So rebar is the reason concrete structures can handle so much weight and stress.
Exactly. It was a total game changer in construction, allowed us to build much taller, stronger, more durable structures.
Wow. Okay, so we've talked about the building blocks, the structural skeleton, but the guide also delves into some broader industry concepts like surveying and tendering. Can you give me like a quick overview of what those are all about?
Yeah. So think of surveying as like the starting point of any construction project.
Right.
It's all about accurately measuring and mapping the land, establishing boundaries, identifying potential challenges, and creating a really precise site plan.
So they're like the detectives of the construction world, gathering all the information before anything even starts.
Yeah, you could say that.
Yeah.
And their work is essential for making sure everything's accurate, safe, and that you're complying with all the regulations.
And tendering, what's that all about?
So tendering is basically the bidding process for construction projects. That's where contractors compete to win the contract.
Oh, Okay.
And they do that by submitting really detailed proposals, outlining their plans, timelines, cost estimates, the whole 9 yards.
So it's like a competition to see who can offer the best value and quality.
Exactly. And this process makes sure that the client is getting the best value for their money and that the projects are going to the most qualified contractors.
So there's a lot that happens before we even see anything happening on a construction site.
Absolutely. It's a complex world. There are so many processes that all have to work together to make these amazing structures come to life.
All right, listeners, we've laid the groundwork here with some essential construction terminology. We're going to build on that knowledge in part 2, so stick around. We're back and ready to dig even deeper into the language of construction. In part 1, we covered those basic building blocks and structural elements.
The foundation, so to speak.
Exactly. Now, I'm curious about some of those more specialized terms
Okay, yeah.
that really make a structure function. The guide mentions underpinning. I'm vaguely familiar with that, but
Yeah, it's a tricky one.
can you break it down for me?
So imagine you've got an existing house and you want to add a basement or you're building an extension. Essentially, you're putting more load on the foundation. Yeah. Right? So underpinning is all about strengthening and stabilizing that foundation so it can handle that added weight.
So it's like giving the foundation a boost.
Exactly.
Yeah.
Prevents it from settling or even collapsing in some cases.
And is underpinning always a huge project? Like, do you always have to excavate a ton?
Not always. There are actually several different methods.
Oh, okay.
And each one's kind of suited for different situations.
Makes sense.
So one common method is called mass concrete underpinning.
Okay.
And that's where you're literally pouring new concrete underneath the existing foundation to make it deeper and give it more bearing capacity.
So it's like creating a stronger base.
Exactly. You also have beam and base underpinning. That's where they install reinforced concrete beams beneath the foundation.
Okay.
And those transfer the loads to these strategically placed bases or mini piles.
So I'm guessing there's a lot of engineering that goes into choosing the right method.
Oh, absolutely. The soil conditions, the type of structure, the size of the project, all those things matter.
Okay, so underpinning is all about what's happening below ground. What about things that protect a structure from the elements,
Yeah.
like waterproofing?
Waterproofing is crucial. That's all about keeping water from getting into the structure, whether it's through the foundation, the walls, the roof, you name it.
Because water damage is a nightmare.
It is a nightmare. Mold, rot, structural instability, you don't want any of that.
Not at all.
And there's all sorts of different methods for waterproofing. It really depends on the climate, the type of structure, and where that water might be trying to get in.
So like in a rainy climate, you would do things differently than in a desert.
Exactly. So for basements and foundations, you often see these waterproof membranes or coatings applied to the exterior walls.
Okay.
For roofs, it's all about proper flashing
Right.
and making sure everything's sealed up tight around vents, chimneys, anything that penetrates the roof.
It's amazing how much detail goes into just keeping water out.
It is. You got to create a continuous barrier, no weak points.
Yeah.
Speaking of protecting structures, the guide also talks about trusses.
Oh, trusses. I remember those from geometry class.
Yeah.
All those triangles.
Triangles are strong.
Yeah, exactly.
So trusses are frameworks, usually made of wood or steel.
Okay.
And they're arranged in these triangular units.
Mm-hmm.
And that lets them distribute loads really efficiently and span large openings.
So like those big open spaces you see in airports or stadiums, are those supported by trusses?
Often, yeah. Trusses are great because they let you have these long, clear spans without needing a ton of material.
Oh, okay.
So they're really efficient and cost-effective.
So they're like the hidden heroes of architecture.
You could say that.
Yeah.
You don't always see them. They're often concealed within ceilings or roofs, but they're doing a lot of work.
Okay, so we've talked about what supports the structure from below and above, but what about during the construction process itself? The guide mentions scaffolding.
Yeah, scaffolding.
Yeah.
Essential for safety. It gives workers safe access at all those different heights.
Okay.
The guide talks about two main types: tube and coupler scaffolding and system scaffolding.
I'm picturing those classic metal poles and platforms. Is that tube and coupler?
That's it. Tube and couplers, super adaptable.
Okay.
Workers can create all sorts of custom configurations on site, so it's often used for more complex projects or where you need a lot of flexibility.
So it's like a giant erector set for construction.
That's a great analogy.
Yeah.
System scaffolding, on the other hand, is more prefabricated, so the components are designed to fit together really quickly and easily.
Okay.
So it's often used for more straightforward projects where speed and efficiency are key,
Got it.
like a quick exterior painting job, for example.
Makes sense.
So each type has its advantages depending on the project.
Wow, so many different considerations, even for those temporary structures.
It's all about safety, efficiency, using the right tools for the job.
Absolute. Okay. Let's move from those external structures to something essential for a comfortable interior.
Mhm.
HVAC.
HVAC. We all know and love HVAC.
Exactly. Heating, ventilation, air conditioning, it's one of those things you don't think about until it's not working.
Until you're too hot or too cold.
Right, exactly.
It's like the silent hero of indoor comfort.
Yes.
It's controlling the temperature, the humidity, the air quality.
The guide mentions some key components like ducts, vents, and thermostats.
Right.
Okay, so I know ducts are the pathways for air, but what's the difference between a vent and a thermostat?
Okay, so vents are the openings that actually let the air into or out of a room. You know, those grills you see on the walls or ceilings.
Okay.
And the thermostat is like the brain of the system.
Got it.
It's what senses the temperature and tells the system when to turn the heating or cooling on or off.
So the thermostat is like the conductor of the orchestra, keeping everything in harmony.
I love that. That's a great way to think about it.
And the guide also touches on the difference between joists and beams.
Oh yeah, joists and beams, those are easy to mix up.
I always get those confused.
They're both horizontal structural elements, but they have different roles to play. So beams, those are the heavy lifters. They're spanning those big openings, supporting those major loads from above.
Okay.
Joists, on the other hand, are lighter, and they're spaced closer together. They typically support floors or ceilings,
Okay.
and they transfer those loads to the beams.
So beams are like the main cables of a suspension bridge, and the joists are like the smaller cables that make up the deck.
Yeah, you got it. It's all about that hierarchy of structural support.
Wow, this is making me realize how much planning and engineering goes into every aspect of a building.
It really is. Construction is a super intricate puzzle. Every piece has its role.
Okay, listeners, we've gone over some more specialized construction terms, learned about the hidden complexity that keeps buildings functional and comfortable. Get ready for our final part where we'll wrap up this deep dive and put it all together. Okay, we're in the home stretch of our construction terminology deep dive. We've covered so much, from those basic foundations to all those specialized systems.
It's been quite a journey.
It has. What else do we have to explore?
Well, we've got a few more gems to uncover.
Okay.
Each one kind of sheds light on how these structures are built and how they function. Let's start with brick masonry. Sounds simple, but it actually involves a lot of skill and artistry.
Yeah, when I think of brick masonry, I just think of stacking bricks. What's more to it than that?
It's so much more than just stacking. You know, think about all those intricate patterns and bonds you see in those historic brick buildings.
Right, right.
That's all thanks to the bricklayers, or the masons, as they're called. They use all sorts of different laying techniques and mortar joints to create these visually appealing and structurally sound walls that last for centuries.
So it's like a blend of engineering and artistry.
Exactly. A good mason, they understand how to distribute the weight, how to create arches and curves, and how to make sure that wall stays stable and durable for, years to come.
Wow, that's incredible. Makes you appreciate those old brick buildings even more.
Yeah, it's centuries of tradition and knowledge passed down through generations.
Okay, so let's move from building walls to holding back the earth. The guide mentions retaining walls.
Ah, retaining walls. Crucial for so many projects.
Yeah, I'm thinking of those walls you see along hillsides or highways, preventing the soil from eroding.
Exactly. So anytime you have a change in elevation, you need a retaining wall to hold that soil back.
Okay.
It prevents it from collapsing and causing damage, or creating a safety hazard.
So it's not just aesthetics, it's actually solving a problem.
It's all about engineering a solution. And the choice of material, whether it's timber, concrete, stone, even those interlocking blocks, that all depends on how high the wall needs to be, what the soil's like, and what kind of look you're going for.
So construction is all about understanding those forces and finding the right solutions.
You got it. And speaking of finding solutions, let's talk about blueprints and work breakdown structure, or WBS as it's often called.
Okay.
Those are two essential tools for planning and executing any construction project.
I've always been fascinated by blueprints, those detailed drawings.
Yeah. Blueprints are like the visual language of construction.
Right.
They show the layout, dimensions, the materials, all those little details you need to bring an architect's vision to life.
So they're the instruction manual for building.
Basically. And then you have the work breakdown structure, the WBS.
Okay.
And that focuses on breaking the project down into these manageable chunks.
Okay.
It's hierarchical. It outlines all the tasks from the big picture down to the tiniest details.
So blueprints show what needs to be built, and the WBS shows how to build it.
Perfect summary. Blueprints are the roadmap. And the WBS helps you actually get it done.
So you kind of need both to keep things on track.
Absolutely. You can't have one without the other. All right, let's talk about something that shapes our cities, influences how we live and work. Zoning regulations.
Okay, we touched on this earlier.
We did.
But I'm ready to go deeper.
Yeah. Zoning's super important. It's all about creating a well-organized, functional urban environment. It dictates things like building heights, how far back you have to set the building from the property line, how dense a neighborhood can be, even what types of businesses can operate in certain areas.
So it's like a set of guidelines to make sure everything's compatible.
Exactly. You wouldn't want, a noisy factory right next to a quiet residential neighborhood, right? Or a skyscraper blocking everyone's view of the ocean.
Right.
So zoning helps balance all those different needs, the residents, the businesses, the environment, all of it.
It's like a conductor for a city, making sure everything works in harmony.
That's a great way to put it.
Yeah.
And, zoning can sometimes seem restrictive.
Yeah.
But ultimately, it's there to protect property values, make sure things are safe, and make our cities livable and enjoyable places to be.
Right. You need some kind of control, some planning involved to prevent things from becoming chaotic.
Exactly. Make sure that development actually benefits everyone. Speaking of community benefits, let's wrap up with green building.
Oh, green building. That's all about sustainability, right?
Yeah. It's about using eco-friendly materials, minimizing that environmental impact.
Okay.
But it's more than that. It's a whole approach to building, thinking about everything from where you choose to build to energy efficiency, water conservation, indoor air quality, you name it.
So it's not just the materials themselves, but how you use them, how the building operates, its impact on the environment.
You got it. It's about thinking long term, considering the entire life cycle of a building.
Okay.
And there are certifications like LE that stands for Leadership in Energy and Environmental Design. And that helps evaluate and recognize buildings that meet these really high standards of sustainability.
I've seen those LE certifications, so like the higher the rating, the greener the building.
Exactly. LE gives builders and developers a framework to work with, encourages them to prioritize those eco-friendly practices.
This has been incredible. I feel like I've learned a whole new language and really gained a deeper understanding of how construction works.
It's been fun exploring with you. And remember, this is just the tip of the iceberg. There's so much more to learn about the art and science and engineering that goes into building the world around us.
I encourage everyone listening to look at those buildings with a fresh perspective.
Yeah.
Once you understand the language of construction, it really does open up a whole new way of seeing things.
And maybe you'll even be inspired to build something yourself.
Exactly. Until next time, keep exploring the fascinating world of construction.